Algebra 2 Honors Lesson 9.3, Graphing Rational Functions. Okay. In this lesson, you're going to learn how to find points of discontinuity, also known as holes, how to find vertical and horizontal asymptotes, and the x and y intercepts of rational functions. Okay. So first thing, let's talk about what an asymptote is. An asymptote is a straight line. Okay. Now it can be vertical, horizontal, or slanted. Okay, toward which the graph approaches. All right, a graph can cross horizontal and slant asymptotes, but not vertical ones. All right, so taking a look at some of these graphs down here. All right, so we have vertical asymptote for this one over here. We have a vertical asymptote going down right here. All right, and also another vertical asymptote going down right here. Alright, as you can see from the graph. Now, these vertical asymptotes, you notice how the graph, it gets really close to the vertical asymptotes, but it never touches them. Okay, the idea is that the graphs approach the vertical asymptotes, but they don't touch the vertical asymptotes. Okay, the graph can cross, or touch horizontal and slant asymptotes, but not vertical ones. Okay, so keep that in mind. And also right here, let me just make a note of it in red. You notice how the graph gets really close to the x-axis? That's because there's actually a horizontal asymptote right here at y is equal to 0, alright, which is the x-axis. So there's also a horizontal asymptote, alright, for this graph here, because the graph gets really close to this horizontal asymptote, but alright, it doesn't touch it. Okay, but it's not touching this one. But keep in mind, graphs can cross and touch horizontal or slant asymptotes. Okay, we're not going to focus on slant asymptotes too much, alright, in Algebra 2. So here's an example of a slant asymptote, alright, and you'll learn how to find slant asymptotes in pre-calc and pre-calc honors next year. But graphs can also have slant asymptotes, alright, and the idea is the same. Alright, the graphs usually approach them and get really close to, alright, but they can't, you know, touch if they're vertical. But if they're slant or horizontal asymptotes, they can't cross or touch. Okay. Over here we have two vertical asymptotes, right? And also a horizontal one. So we have two vertical asymptotes and then a horizontal one. Now you notice the graph in the middle here, it crosses the horizontal asymptote, which is perfectly fine, right? Remember, the graph can cross horizontal or slant, just not vertical. Now the vertical asymptotes right here, right? You notice the graph, it gets really close, but it's not going to touch. Over here it gets really close, it approaches, but it doesn't touch. Alright. Over here it gets really close, but it doesn't touch. Okay? It gets really close up here, but it doesn't touch. Okay? So that's the whole idea of what an asymptote is. Alright? Let's talk about how to find a vertical asymptote now. Or actually, let's talk about points of discontinuity first. Points of discontinuity, also known as a hole, right? It's a point where the graph is not continuous. So taking a look right here, so we have a straight line kind of going up, and then right here there is a hole at x is equal to 2, or at x is equal to 2. There's a hole or a point where the graph disconnects, right? And then it continues after 2. So this part right here, that's called a hole or a point of discontinuity. It's just a point in the on the graph where is not continuous anymore. Okay, so right here there would be a hole at x is equal to 2. All right, because on the x-axis right here there's a hole at x is equal to 2. Same thing idea over here. There's also a hole at x is equal to 2. Okay, at x is equal to 2. So the graph is going, all of a sudden there's a hole, then it continues. Okay. So let's talk about how to find a point of discontinuity. So after you've factored, all right, let's take a look at it. So here's the actual function, and here's the graph for it. So after you've actually factored everything, to find any possible holes, okay, not every graph is going to have a hole. To find any possible holes, if you have any factors that cancel out, so you notice here that the x minus 2, these cancel out, right? that these cancel out. So the factors that cancel out, just think, when will they make 0? Alright, when is they going to make 0? Or just take the factors and set them equal to 0. Alright, so when is x minus 2 going to equal 0? When x is equal to 2. So you know that you have a whole at x is equal to 2. Okay, so any factors that cancel out, okay, from the top and the bottom. Like over here, oh, we have just by coincidence x minus 2 again, so those canceled out. So any factors that cancel out, set them equal to 0. Alright, and those are your wholes. Okay, so you know you also have a whole that x is equal to 2. Okay, so let's find some vertical asymptotes. Now, how do we find vertical asymptotes? Now, vertical asymptotes, so that's how you find wholes. Vertical asymptotes, so let's take a look at this example over here. So these canceled right there, right? So those are your wholes. What's left over in the denominator, if you take what's left over in the denominator, right, and set it equal to 0, those are your vertical asymptotes. So since x minus 1 is left over, right, in the denominator, set it equal to 0. So at x is equal to 1, we have a vertical asymptote. Alright, I abbreviated VA. So we have a vertical asymptote at x is equal to 1. Sometimes you might just say there's a vertical asymptote at 1. Alright, just understand it's a vertical line at 1 on the x-axis. Okay, so whatever's left over after you factored everything and canceled, whatever's left over in the denominator, those are your vertical asymptotes, the values that basically set that factor equal to 0. Alright, so let's see some examples. So let's find some vertical asymptotes and wholes. So everything's already factored out, right? Usually it's not factored out, so you would have to factor. But everything's factored out here. So does anything cancel out? It doesn't look like any factors cancel out. So there would be, alright, no wholes for this one. Now vertical asymptotes. So these are left over in the denominator. So when are we going to have 0 on the bottom? When x is equal to 2, when x is equal to 3. Okay, so we know that if we were graphing this at x is equal to 2 and 3, we would have vertical lines, alright, vertical asymptotes, alright, at those points. Over here, let's take a look. Do we have any wholes? Well, these do cancel out. So wholes, alright, at x is equal to 2, we're going to have a whole. And then anything in the denominator left over? Nope, nothing in the denominator left over. So we have, alright, no vertical asymptotes, none. Okay. Over here, x minus 3 is canceled. X plus 4 is also canceled. So we have wholes at x is equal to 3 and x is equal to negative 4, right? And then here's where you have to be careful. Now, right here, x is equal to 3 is also left over, right? So normally you would say there's a vertical asymptote, alright, at 3, alright, at x is equal to 3, obviously. Alright, vertical asymptote at x is equal to 3. Right? Now we also have a whole at 3. Since we have a vertical asymptote at 3, right, that means that if we have a graph where we have a vertical line at x is equal to 3, that means it's not necessary to say that there also needs to be a whole at x is equal to 3. So when you have a whole and a vertical asymptote at the same spot, alright, you just need to only list the vertical asymptote, because I mean the graph is never going to cross or touch the vertical asymptote, so we know that there's always going to be a discontinuous point at the vertical asymptote. So no need to also state the whole. Okay, so these canceled out, and normally this would be a whole, but since this is also left over, so at 3 you should say there's a vertical asymptote. So just think of it as the vertical asymptote overrides the any wholes if the values are the same. Alright, so real quick, let's just find any more wholes and vertical asymptotes for these problems here. So over here everything's factored out, so it looks like we'll have any wholes, nothing cancels, so none. Vertical asymptotes at x is equal to 1, because that'll make 0. At x is equal to negative 3. I probably shouldn't put an equals on here. Let me just put vertical. There we go. Same thing over here. Looks like these cancel, so we have a whole at x is equal to 2, and then a vertical asymptote Alright, vertical asymptote at x is equal to -3. And then over here, let's factor this first. So this would be x plus 1, x minus 1. So the x plus 1s will divide out. So that means that we're going to have a hole at x is equal to -1. And then vertical asymptote, alright, nothing left over on the denominator, so none. Okay, so pretty easy to find the holes in vertical asymptotes. Let's talk about horizontal asymptotes. So let me summarize this for you real quick. So first of all, the graph of a rational function has at most one horizontal asymptote, right? So the graph, a rational function can have one horizontal asymptote at most, okay, at most. So it can't have more than one. 2, basically this says right here, the degree, right? So we're talking about the degree, which is the highest exponents, the highest degree. If the degree of the denominator, right, is bigger than the degree of the numerator, your horizontal asymptote, right, your horizontal asymptote will be the line y is equal to 0. Alright. Now if the degree of the denominator is equal to the degree of the numerator, your horizontal asymptote is going to be the line y is equal to a over b, where a and b are the coefficients of the highest exponents. Okay. And then if the degree of the denominator is less than the degree of the numerator, then you have no horizontal asymptotes or none. Okay. What you're gonna have is a slant asymptote, and basically slant asymptotes, you divide the top polynomial divided by the bottom, and your answer would be the equation of the line. That's the slant asymptote. All right, but you'll focus more on that in a pre-calculus. All right. So let's summarize this so it makes a little bit more sense to you. So let's say we're trying to find horizontal asymptotes, right? And let's say the problem, all you really care about is the highest degrees. So let's say you have some function f of x is equal to 2x to the third, blah 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 blah, over x squared. So if the highest exponent on top is bigger than the denominator, the numerator, the highest exponent here is bigger than the denominator, so that means that you're going to have no horizontal asymptotes, none. If they're equal, let's say 3x squared, blah 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 blah, over 2x squared, blah blah blah. So if they're equal, the coefficients of the x, your horizontal asymptote would be the line y is equal to 3 over 2, or 1.5. Okay, so that means that you're gonna have a horizontal line at 1.5, right, on the graph. And then if the denominator happens to be bigger, let's say x to the third, x, blah blah blah. So if the denominator, the degree of the denominator is bigger, alright, then that means your horizontal asymptote is the line y is equal to 0. Okay, y is equal to 0. Alright. One thing to mention, let's say you have like 1 over some polynomial, x squared or something like that. So there's nothing to compare here, so you have this situation. Alright, you would also have no horizontal asymptotes. Alright, this would also be none. Okay. So now let's take a look at an example here. So find any vertical asymptotes, holes, and horizontal asymptotes. Okay. So first we're going to need to factor this problem right here. So over here we would first take out the 2, obviously. You end up with, actually let me do that in the top. So let's factor out the 2. and then you're going to end up with x squared plus 5x plus 6. So let's fully factor this. We'll end up with x plus 2, x plus 3. Let's factor the bottom. X plus 2, x plus 1. And anything cancel out? Looks like the x plus 2's cancel out. So if something cancels, that means we have whole. So we will have a whole at x is equal to -2. Okay. Vertical asymptotes. Vertical asymptotes. What's left over on the bottom? X plus 1. So we're going to have a vertical asymptote at x is equal to -1. Okay. And then horizontal asymptotes. Let's compare the degrees. Oh, they're the same. So basically we're doing 2 over 1. So the horizontal asymptote is the line y is equal to 2 over 1, which is just 2. Alright, real simple. Alright, nothing difficult about that. Let's talk about x and y intercepts now. So to find the x and y intercepts of a rational function, right? So to find the x-intercepts, alright, set the factors, alright, from what's left over, right? So if stuff cancels out, you can ignore it, alright? Whatever, if something cancels, if factors cancel from the top and the bottom, you can ignore it, alright, when you're finding x-intercepts. So set factors from what's left over, alright, from the numerator, okay, equal to 0. To find the y-intercept, alright, of the rational function, set x equal to 0 in the original equation. I find that's probably the easiest way. Okay, so let's take a look at an example. So over here we're going to find everything. Alright, so let me first factor this right here. This looks like the problem we just did. So we have 2, right, x squared plus 5x plus 6. So then we ended up with x plus 2, x plus 3, right? So this was the example we did earlier. This is x plus 2, x plus 1. So let's kind of piece the whole lesson together. So these canceled out, remember? So we have a whole at x is equal to -2. Okay. Vertical asymptotes. This was left over, so we have x is equal to -1, vertical asymptote. Horizontal asymptote. These degrees are the same, so it's the line. So we take a look at the coefficients, 2 over 1. So it's the line y is equal to 2. Let me change these. Let's just semicolon these. So there's only a bunch of equal signs. And then now let's talk about x-intercepts and y-intercepts. To find the x-intercepts, whatever's left over, right? So what's left over here? This factor right here, x plus 3. So when is this going to equal 0? When x is equal to -3. Alright, that's when this is going to equal 0. Basically all you're doing is you're taking x plus 3, you're setting it equal to 0. So that's why you get -3. Then to find the y-intercept, right? You notice here, since the x plus 2 canceled, we don't care about that for when we're finding the x-intercept. Now the y-intercept, to find the y-intercept, just go to the original problem, right? And you're setting all these x's equal to 0. So to find the y-intercept, you set x equal to 0. So if this is 0, if this is 0, if this is 0, if this is 0, right? Well, anything 0 squared is 0, anything times 0 is 0. And basically all this is going to be 0, so you're left with, well, just 12 divided by 2, which is 6. So your y-intercept is going to equal 6. Okay, it's going to equal 6. So now what happens is, let's put everything together, right? So if you're actually graphing this, we have a whole at x is equal to -2. We'll talk about that in a moment. The vertical asymptote, right? The vertical asymptote is -1. So we have a vertical asymptote at -1. Let me just dash this, and I'll do it in blue. So at -1, we have a vertical asymptote. So here we go, -1, right? -1 on the x-axis. We have a vertical asymptote. Horizontal asymptote is y is equal to 2. So here's 2 on the y-axis, so we know we have a straight line that goes through it. Okay. X-intercept is -3. So right here, you notice on the x-axis, the graph crosses through -3. The y-intercept, y is equal to 6, the graph crosses through +6 on the y-axis because that's the intercept. And now, if you were to actually graph and make a table and everything, you'll find out that the graph, looks like this, okay, and the graph looks like this. Now, the whole part, right? This right here is the whole, and normally you leave it kind of empty and not fill it in. Okay, it should actually be empty and not filled in. So what it means when we say there is a hole, all right? If we say the hole is x is equal to -2, that doesn't mean that there's a hole right at -2 on the x-axis. What that means is as the graph, all right, as the graph moves, once it gets to -2 on the x-axis, at that point in the graph, that's where the hole will be. All right, so don't think that if we say the hole is x is equal to -2, that means that, oh, there's a hole right there. That's not what that means. Okay? So let's do one more problem where we kind of find everything. Let's do one last problem right here. Let's take a look at this one down here, number 5. So first you would factor everything. Let's factor out the 4. You get x squared minus 25. So you're going to end up with 4 times x plus 5, x minus 5. On the bottom, let's factor this guy right here. We're gonna, can we take anything out? Nope. So let's do the x right here real quick. 2 times -15, -30, and we're trying to get 1. So it looks like +6, -5. And then we're dividing by 2. This is our chapter 5 review stuff. So let's reduce that 3 over 1. So our factor will be x plus 3 and 2x minus 5. Alright. So, let's see if anything cancels out. Does anything cancel out? Nope, it doesn't look like anything cancels out. So, no holes. Vertical asymptote. Let's take the denominators. These were left over. So, at x is equal to -3, we'll have 1. At x is equal to +5 over 2. Alright, if you have a number in front of x, remember to do the opposite sign, divide by 2. Horizontal asymptote. Let's look at the values. Oh, these are the same, so look at the coefficient. 4 divided by 2, so we know it's going to be the line y is equal to 2. X-intercept. To find the x-intercept, that's what's left over on top right here. Oh, this is left over right here on top. So basically we're kind of two of them. X is equal to 5, x is equal to -5. And then for the y-intercept, we're going to substitute 0 in the original problem. So this is all going to be 0. So basically you end up with -100 over -15. So negative is positive. So you're going to get basically you're going to have y is equal to, and reduce that by 5, so you'll get 20 over 3. Okay? And you were actually going to plot this, you would just change that to a mixed number. Okay?